Right, good morning. Good morning. You're welcome to Tutorials with Fametanti the Schoolboy. Today we'll take a look at chemistry. And as I told you in our last class here about the division we had, we've separated wire classes from jam classes. So what we do here is what Saturdays and Wednesdays is purely WAEC classes. We follow the WAEC syllabus here, but in the other center we follow JAM and other entrance exam syllabus. So we are based on that. In the last class, in our last chemistry class, we concluded with solubility or so. Okay, it remains application of solubility, but because of this division, we were doing that time using JAM syllabus. So because of that division, we will continue that in the other class. Okay, but we follow strictly starting from the beginning of the syllabus with chemistry here. So the first Madam, is this 9 o'clock? What's time? You're coming one hour late to class. I can see. You're coming 1 hour late to class. After you look for how to take the assignments, I've cleaned some from 1 to 4. So after you copy the assignment from others, you're meant to be here before 9 a.m. Now, the introductory part of this syllabus talks about chemistry, what chemistry is all about, which I believe we have done. I don't want to start going there again, okay? We have done that then, and in fact, we've done that to a very great extent. And we have also talked about scientific methods. That is the first topic here. I believe we have also done that. We've done that in chemistry. We've done that in biology. So I don't think we have any issue. You have any issue with what? Scientific methods. Do you think you have any issue with it? So let me know whether we have issue with that or not. I'll ask us some questions now. So the ability to answer these questions will help me make an informed decision whether to go back or to continue with where I want to start from today. All right. The first question says, chemistry is defined as A branch of knowledge which produces chemicals. B, a branch of science which makes physics and biology clearer. C, the oldest branch of science. D, the branch of science which deals with changes in matter. D. C. D. Are you sure? Okay. Number 2. The answer is D. Number 2. We study chemistry to acquire knowledge about A, bioscience, B, theory, C, matter, D, hypothesis. Matter. Are you sure? I hope you just following what she's saying. Okay. Now, number 3. Studying chemistry gives us training in A, scientific method, B, burning fuel, C, oil and margarine, D, rotting leaves. A is what? Is Chibuzo? A is what? Okay, the answer is A. Number 4. Scientific approach to discoveries follows the order which includes A. Further experiment and problem solving. B. Theory, negative and positive results and experiments. C. Experiment, hypothesis and results. D. Observation, hypothesis and experiments. Huh? You get so options. Okay, I should dictate the options again. The question says scientific approach to discoveries follows the order which includes the order of scientific method. A. Further experiment and problem solving. B. Theory, negative and positive results and experiments. C. Experiment, hypothesis and results. D. Observation, hypothesis and experiments. C is what? Results. Chinwe. D. D is what? Say what D. And what? So you don't even know the option you are picking. No, if you pick another, you should reproduce the option. True of us? Yeah, because it's the content of the option that made you to choose the what? Option. So if you cannot reproduce, so then why did you choose D? Do you understand my argument now? Unless you are doing tom-tom. Is even correct? Let me call the options again from A to D. Further experiments and problem solving. B. Theory, negative and positive results and experiments. C. Experiments, hypothesis and results. D. Observation, hypothesis and experiments. C. Experiments, hypothesis and result. You. Chibuzo. Experiment. You. So Michael and the what do you say? Experiments, hypothesis and result. Michael and the Chinwendo.
It's confusing. It feels like it's meant to be D because that's the observation. But there's a way it ended. Hypothesis before experiment.
So what do we discuss in scientific method? What are the methods what are the steps we discussed?
Observation. Experiments. Observation. Experiments. Observation, experiments, hypothesis, and theory. And results.
Is that what we discuss in this class? So you observe and go and rush and go and start doing experiment. What do you want to experiment on? It's not when you observe. You from your little understanding of what is going on in that particular environment or whatever you observe, you could put up a what hypothesis to trying to explain what you observed. Then you need to test it to know whether that observation is true or not by carrying out what? Experiments. So after the experiments now, if the experiment gives a result that is in line with your what? Hypothesis, you can say okay, and the other scientists or bodies also carry out the same experiment and it's giving the same result. You can say okay, is that not when it will proceed to what? Theory. So you don't observe and rush into it, and then after observing, you carry out experiment before you start giving hypothesis. The experiment is there to prove your what? Hypothesis. But if your hypothesis is, if the experiment is not in line with your hypothesis, that's when you now say you can reject the what? hypothesis and go back to observe again and propose another what? Hypothesis. And carry out another what? Experiment. So the answer is what? D. Good. Okay, number 5 says chemical hypothesis is different from chemical law in that chemical hypothesis is different from chemical law in that A. Hypothesis is reasonable, while law hypothesis is not reasonable, while law is reasonable. B. Hypothesis is a reasonable explanation hypothesis is a reasonable explanation to observations made, while law is a statement from a scientist. C. Hypothesis is a reasonable explanation to observations, while law is a statement which confirms the hypothesis after extensive tests. D. None of the above.
C.
C is what?
Hypothesis is an experiment to what to
Is a reasonable explanation.
of what to go from observation.
Okay.
While law is a statement that is confirmed after further
Test. Okay. You? The same thing with what you said. You? The same thing. You? Okay. Maybe I will change direction now. I'll change. Let me know whether all of you will follow the person. So the answer is actually what? C. Right. Number 6. Dash is established. A dash is established only after the theory has been extensively tested and proven true without any exception. A dash is established only after the theory has been extensively tested and proven true without any exception. A. Theory. B. Hypothesis. C. Medicine. D. Law. No, I'll point. You. Chibuzo. Chibuzo, answer your question. Law. You. Okay, it's law. Because it's when you have actually extensively tested. A lot of scientists work on the theory and it gives the same result consistently. They now say beyond no exception, any part of the world doing the same thing, no exception, can now say yes. This becomes a what? A law. Now number 7. When hypothesis has been tested and found to be true within the limits of available evidence. When hypothesis has been tested and found to be true within the limits of available evidence, it becomes A. Hypothesis. B. Experiments. C. Positive results. D. Theory. Come see. Theory. Theory. The question: when hypothesis has been tested and found to be true within the limits of available evidence, it becomes A. Hypothesis. B. Experiments. C. Positive results. D. Theory. Theory. Good. The answer is theory. Number 8. All are careers in chemistry. Except A. Pollution. B. Agriculture. C. Forestry. D. Food processing. Chinwe. Pollution. Right? Pollution. Chibuzo.
Pollution.
Pollution. Are you sure? So pollution is not a career in chemistry. Are you sure?
So food processing.
Huh?
Food processing.
Huh?
Food processing.
Are you sure? Ah, she's confused. How can pollution be a career? Even though if you go into environmental health or sciences, call it health science, you can build a career in environmental health science. You can actually you can now think of look at how pollution, you can study about pollution, but not that pollution is a career. Okay? In chemistry, it's not, okay? Alright, so the answer is what? Pollution. Number 9. Which one of the following is a career in chemistry? Which one of the following is a career in chemistry? A. Medicine. B. Philosophy. C. Geology. D. Geologist. C. Oil spillage.
Medicine.
Huh? Medicine. Huh?
Medicine.
Medicine. All right. That's the answer. Number. Huh? Don't worry, I will soon start acting skit. I will be calling you. Skit. Comedy skit. Sure you like it? Alright, number 10. The public and private sectors. The public and private sectors which offer job opportunities are all except A. Radioactivity. B. Health service. C. Food processing. D. Forestry. The public and private sectors which offer job opportunities are all except A. Radioactivity. B. Health service. C. Food processing. D. Forestry. Radioactivity. Huh? The public and private sectors which offer job opportunities are all except A. Radioactivity. B. Health service. C. Food processing. D. Forestry. Radioactivity. Okay, that's good. Number 11. Dash has helped to increase food production. Dash has helped to increase food production. A. Mobile. B. Fertilizer. C. Man-made fibers. D. Space science. Huh? Fertilizer. The question. Dash has helped to increase food production. A. Mobile. B. Fertilizer. C. Man-made fibers. D. Space service. B is what? B is what? Okay. Number 12. These are adverse effects of chemistry. These are adverse effects of chemistry, except A. Pollution. B. Population. C. Corrosion. D. Drug abuse. Confusion everywhere. Let me repeat the question, please. These are adverse effects of chemistry, except A. Pollution. B. Population. C. Corrosion. D. Drug abuse. Population. Population. Okay. Now, number 13. Rusting can be prevented by the following. Rusting can be prevented by the following, except A. Alloying. I think we discussed alloy in this class. Alloying. B. Cathodic protection. C. Supportive method. D. Application of protective coating.
C.
C is what?
Supportive method.
Huh? What's the answer? You don't know? Are you serious? Okay. We discussed rusting when we talked about chemical changing. We discussed rusting in two different occasions. When we discussed adverse effect of chemistry, because rusting is a chemical reaction. It's not. It's a chemical change. So it's chemistry. So one of the adverse effects of chemistry, one of them is what? Rusting. That's why you can, if you, before the advent of this aluminum thing, before zinc, if the building stay for like 5 years, 10 years, in Igbo language you will say that no bagogeni chala. In English, in chemistry, is rusting. And once it start rusting, that's the thing is spoiling, right? Then you buy some metallic, even your tank, and some metallic pipes, they will start rusting. And once it starts rusting, that thing will start doing what? And it would not even be good for, if you use it to store what you consume, it's not good for to your health. Hope you know. Are you aware? So it's an adverse effect of chemistry. We discussed it. We also discussed it when we discussed the chemical change and physical change, right? We say rusting is one of the chemical changes, because you cannot recover the iron again. True of us. Now, but we didn't go deep into actually, if we know it's an oxidation process, what actually happened, what compound is formed when iron is oxidized during rusting. We didn't go there because it's not the topic. Now, there we talked about the rusting, and here now the question is trying to know whether you know if the ways you can prevent the rusting. I can remember vividly that we mentioned alloying. An alloy is a mixture of two or more metals, right? The idea is that it prevents rusting. It actually prevents rusting. Am I communicating? Something like steel now. Steel is an alloy of what and what? Steel is an alloy of what and what? I won't tell you, find out and let me know. But the point I want to make here is that find out what and what is steel is an alloy of what. Today there are some people. Have you heard of stainless steel? Stainless steel, they don't rust, right? The reason is because it's an alloy. Now, but some people will go say that they are producing stainless steel. See, do you know what they would? Have you ever bought spoon? They say it's stainless steel spoon. You buy it and keep at home. After like 2 months, 3 months, it will start rusting. Who has experienced that? That thing is not actually stainless steel. Do you know what they did? They coated it. I'm sorry to you as what? Stainless steel. After some time, the coating may do what? Wear out, and the coating is not even done. They didn't even do it well, because proper coating, real coating, lasts. Are we together? So you can prevent rusting by alloying. For alloy itself is the best, but now it's expensive. So coating can be a bit cheaper. But if you coat well, it can still last for some time, for a long time anyway. But once you notice that the coating has started where you can stop using that thing. Am I communicating? Now, That means you can prevent rusting by what? By what? Alloying. You can also prevent by what? Coating. That's what this question want to test your knowledge on. That's why option A is what? Alloying. Option B is cathodic protection. You can use if you go into electrolysis, you understand what we mean by what cathodic protection. I don't want to go into that, but with that you can prevent what? Rusting. Okay. Now, the same thing with application of protective what? Coating. I think I mentioned that one. We'll go into that. We'll go deep into that with time. This is just the introduction. Okay. I don't want to start going into the process that what is involved in each and each and every one of them. But this is supportive. Doesn't make sense. Supporting what I supported. Now how will you support the metal so that it will not rust? It makes no sense. The iron so that it will not rust. Does it make sense? So that's why C is the what? Answer. I think do you now understand why C is the answer? If it's supposed to be I'm explaining it because you said you wouldn't know the answer. Now I think with this I think at least I can beat my chest and say okay, at least up to 60%, 70% at least I'm okay. Now we are going to the second phase. The topic for today is structure of the atom. So let us now go to the structure of the atom. Let's go to the structure of the atom. That's the topic for today. Structure of the atom. So, from your SS1, from your JS, your basic science, at least you did atom there, right? True of us. Your basic science, right? JS 1, JS 2, JS 3. True of us. So atom is no longer a new word to you. So what is an atom? Smallest what? Of what? Is it true? Okay, she added that can take back the chemical reaction. Is it true? You're not sure? What's an atom? Is it true? Alright. Now, in our first class on this subject, chemistry, I told us that everything is what? Chemistry. Chemistry is what? Life. There is nothing in this life. There is nothing in this life you can think of that exists. Even the air you cannot even touch. You can't even see. There's nothing in this life that if you break the thing down, you will not get to what? Elements. Chemistry is everything. Give me an example. As you are now. If I break you down now, is element I will see. It's elements. As you are now, even all these clothes you are wearing, the watch you are wearing, everything you are wearing from your head to your toe is carbon, hydrogen, oxygen, some nitrogen, sulfur will enter. That's all. Carbon, basically carbon, hydrogen, oxygen, then sulfur, nitrogen will enter. Phosphorus, maybe your DNA and some things you are wearing. That's all. This table now, break it down. It end up in what? Carbon, hydrogen, oxygen. Maybe because of this thing, this wood finisher, you may start seeing other elements. Maybe nitrogen or whatever, sulfur, depending on the components. This plastic, break it down. Carbon, hydrogen, oxygen. The air, the paper, carbon, hydrogen. Cellulose is what? From where? Carbon, hydrogen, oxygen. Name the nothing. Just name it. Even the sand, the sand the sand is what? Silicon, oxygen. There's nothing you can think of. Name it. End up in what? Elements. That's why I said that chemistry is what? Life. Chemistry is life. Chemistry is everything. That's why they define that an atom is the smallest what? Of what? An element. That can take part in a what? Chemical reaction. And that's why they say that chemistry is the study of what? Matter. And what is matter? Matter is anything. They say anything that has mass and occupies what? Space is a matter. Whether you can see it or whether you cannot see it, it's a matter. So matter is everything. And that's what chemistry studies. So chemistry is everything. I so much love the subject. If you understand chemistry, there's nothing you not understand in this life. Now, as we want to study this atom, what do you want to study on in this atom? We want to now look at the gross feature, what the features of the atom, the gross overall features of the atom, how atom look like. But before we can do that, we do that looking at the works of some what? Scientists that actually did their best to describe this what? Atom. So, the first scientists we will take a look at, because we cannot just jump and start talking about component of atom, the structure, the subparticles, the subatomic particles like neutron, electron, proton, without first of all talking about these men that actually did a great job in different eras anyway on atom. The first person I want to talk about is John Dalton. John Dalton. Have you heard of that name, John Dalton? Have you heard of that name, John Dalton? Whatever Dalton's atomic theory. You've not heard it before. That's why you are here. The man's name is what? John Dalton. So what did John Dalton do? What did he do? In 1808, having studied the structure of an atom, he came up. John Dalton. John Dalton. In 1808, having studied the structure of an atom, he proposed, remember our scientific method. Hello? Remember our what? Scientific method. Remember that, okay? So John Dalton, having studied atom, he came up with a what? Theory. This theory is known as what? Dalton's atomic what? Theory. It's known as what? Dalton's atomic theory. So I'm going to give us a summary of this Dalton's atomic theory and tell you what actually happened. Anything we are doing, they are linked to each other. Now, here is a scientist that extensively worked on the atom and came up with a theory. But after coming up with that theory, first of all, he would have observed something and started propose a hypothesis, right? Possibly up to 1 or 2 times before he came up with the theory. Even his theory, we are all what? Modified. Only one remained. To tell you how serious it is. The theory, there are 5 of them summary, as in the were summarized. Only one was maintained. Others were what? By the works of other scientists, like works of J.J. Thompson, works of Rutherford. We will look at this. We will look at them one after the other. Okay? Now, so this is what John Dalton came up with. John Dalton's atomic theory states that number one, all elements are made up of small indivisible particles called what? Atoms. All elements. Sorry, our reference book for today is New School Chemistry for Senior Secondary School by Oseyo Ababio, 2016 edition, as revised by L.E.S. Apanisi and Herbert Igwe. These are reference book for today. Let's continue. Now, he said that number one, that all elements are what? Made up of what? Small indivisible particles called atoms. That's the first part of his theory. John Dalton also proposed that atoms can neither be created nor what? Destroyed. That's the second one. Atoms can neither be what? Created nor destroyed. Atoms can neither be created nor destroyed. The third part states that atoms of the same elements are alike in every aspect. Atoms of the same element are alike in every aspect and differ from atoms of all other elements. Atoms of the same element are alike in every aspect and differ from atoms of what? All other elements. Kita ka ọga anyị ji abịa akwụkwọ. Ọga anyị na ebe na Malaysia. Izuchukwu. We are coming to a tutorial that a 9 a.m. tutorial by 10:30, 1 hour 30 minutes. It's not a good thing. No. What happened? Work. What type of work? Cooking. You don't know that you should plan yourself well. That you know for how to. You can say, okay, since I come for tutorials on Saturday morning and I come for tutorials Friday evening, okay, let me use Friday morning to do what I should do. So that Saturday morning I'll just boom, go to tutorials. You plan yourself. Sit down. After you collect notes from others, and we have already given the assignment for today's. for chemistry, our chemistry assignment. Please ensure you copied it from others. Now, I said that the third one says that atoms of the same element are what? Alike in where? Every aspect, and differ from what? Atoms of all other what? Elements. Then number four states that when atoms combine with other atoms, they do so in simple ratio. When atoms combine with other atoms, they do so in simple ratios. Remember when we talk about compound, we said that compound contains atoms that are combined in a specific constant ratio. That's why a compound has formula. Remember, so atoms of elements combine to form a compound. True of us. Good. Let's continue. Number 5. All chemical changes result from the combination or separation of atoms. All chemical changes result from the combination and separation of atoms. This is a summary of John Dalton's atomic theory. And there's one thing in science world, once you come up with something, other scientists will do what? Put their head inside that and see whether it's true, whether they can apply it, whether there's anything new they can add to it. So when he published this article, this work, a lot of scientists started looking at it again, reviewing it again, trying to see what they can make out of it, whether there's what is called scientific gap. And what is called gap is when you come up to the university level, you start, maybe you want to go into academics or want to be a researcher. There's what is called gap. You want to see what this person, this scientist, or this researcher's work could not or cannot explain. It's a gap you need to do fill. You now look at the person's work and start doing your own to see whether you can get something that can fill that gap. So a lot of scientists, they didn't go into this because they want to deal with him. No. They went into it because they want to now see. The idea of this whole research is to improve our life. I hope you are aware. That's why they carry out all this research. So, but on the course of doing this thing, they discover a lot of things that John Dalton's theory could not cover, could not explain. They now discovered a lot of things. There are a lot of things he could not explain. Now, when we go into stoichiometry and other aspects of chemistry, we'll start looking at law of conservation of mass, law of definite proportion, right? Have you heard of such, all those ones? And we'll still treat them. But I want to mention some of them. That the atomic theory by John Dalton was just partially supported by the law of conservation of mass, law of definite proportion, and law of multiple proportion. I will still go into that. I just want to mention it, but we'll still treat it. You understand what these laws stands for. You see that these laws are listed now. They just partially supported the theory. But another thing there is that this theory could not explain electrolysis. The theory could not explain electrolysis. John Dalton's theory could not explain Electrolysis. Do you know why? Can someone tell me the reason? Let me know someone that thinks here. Can someone tell me the reason why you think from John Dalton's theory could not explain electrolysis? Who can help us? Who can just let me just hear you ask. Please, my class is an interactive class. I want to train people that are listening, people that think, not people that cram notes. You say what? Okay, here was electrolysis. Don't worry. We'll explain that. We'll still treat it as a topic, okay? Okay? Yeah. But those that know electrolysis, can someone tell us? Now, let me tell you something. Electrolysis. Remember Arrhenius theory, right? About ions, right? Ions. When you pass electric charge, when you pass electricity in a solution of a what? In a solution of a salt or what have you, then the ions will start aligning. Some will go to the positive electrode, some will go to where? Negative electrode. I don't want to go deep into that. This is the basis of what? Electrolysis. Talking about ions. Talking about what? Movement of ions with respect to when electric current is passed and what have you. Now, how can a theory that's proposed that atom is the smallest indivisible particle of an atom explain ions? Is it possible? It can't explain ions. True of us. Because remember, when we treated the components of what? Elements. Sorry, component of matter. Remember, when we treated component of matter. What are components of matter? What are components of matter? No, that is states of matter. States of matter. You just mentioned classification of matter. We have classification of matter. We have component of matter. We have states of matter. State is solid, liquid, gas. Classification is elements, compound, and what? Mixture. But components of matter are what? Ions. Atoms and what? Elements. Molecules. Thank you. Now, how can a theory that's proposed that atoms are what? Indivisible. That means the theory didn't recognize what? Ions. Because ions are what? Ions are what? Good. Now, look at it now. Ions are formed by either when an atom gains electron or loses what? Electron. When the electron is negatively charged, right? While proton is what? Positively charged. True or false? Now, and two of them are equal in an atom. Number of electrons and number of neutrons are what? Electron and the proton, right? And neutron also, the same thing, are equal in what? An atom. That's why an atom doesn't have a charge. Does an atom have a charge? An atom is neutral because the number of electrons has cancelled the number of what? Proton. True or false? So there are no charge. The charge is zero. Now, when an atom gains electron, if you add negative charge on a neutral atom, that atom will have what type of charge? What charge will it have? An atom that is neutral already has equal number of electron and proton. It's neutral. Then it will gain electron. Electron is negatively charged. It will gain electron negative. So what will be the charge of the atom? Positive. How? Explain. An atom is electrically neutral. It has no charge because the number of proton, which is a positive ion, and number of electron, negative ion in an atom is what? Equal. So the positive, if there are 9 proton, 9 neutron, they will cancel each other. True or false? Is neutral. The charge is what? 0. Now, if the atom gains an electron, any number of electron, an electron is negatively charged. What will become the charge of the atom? Negative. So the atom will become what? Negatively charged. It will form an ion, which is a negative what? Ion, because of the charge. Is it clear now? Now, when an atom loses electron, an atom that is neutral, equal number of positive charge and equal number of negative charge. If it loses a negative charge particle, what will become the charge of the atom? Positive. So that means positively charged ions are formed by loss of what? Electron. While negatively charged ions are formed by gain of what? Electron. Now, I just want to explain something. We'll see 3 this at the topic, but I want to explain something. I want to tell you why John Dalton's theory atomic theory did not explain electrolysis. Now, I said that electrolysis deals with what? Ions, right? Now, if John Dalton theories is telling us, proposed that atom is the smallest indivisible. That means that atom you cannot, there's nothing else you can get under atom. That's meaning, right? Right? Now, he did not talk about that's what you call subatomic what? Particles. John Dalton theory did not recognize the subatomic. Sub mean under the atom, particles. And what are these subatomic particles? They are the what? Protons, neutrons, and what? Electrons. So John Dalton atomic theory doesn't know what is subatomic particles, which are the what? Proton, neutrons, and electrons. And before an ion can be formed, the atom must lose what? Or gain electron. So if, according to John Dalton, atom is smallest, doesn't know anything concerning electron, how will he explain ions? That's why John Dalton theory could not explain what? Electrolysis. Because electrolysis involves what? Ions. And ions are formed by loss or gain of what? Electron. And John Dalton atomic theory doesn't know anything concerning what? This subatomic what? Particle. That's why he could not explain what? Electrolysis. Have you now seen? So, from the work of those scientists that discovered, these things were discovered by scientists, protons, neutrons, is John Dalton that called their attention to atom. They started studying and realized that these things exist inside atom. By the time we start going into their work, you see how they discovered neutron, you see how they discovered proton by alpha scattering experiments. You realize that this atom has these particles inside it. But John Dalton's atomic theory didn't say anything about it. It's even telling us that atom is the smallest indivisible. So he could not explain electrolysis. Now, due to this discovery and other things he could not explain, a lot of scientists now entered into atom to study atom. So after this series of experiments and different discoveries, there came the modifications of John Dalton's atomic theory. So let's look at these modifications of his theory. You see how all the 4 of his theory were modified. Only one is maintained till today. Now let's look at modification of Dalton's atomic theory. Modifications of Dalton's atomic theory. Number one, we look at the modification of the first theory, okay? Remember the Dalton the first one said that all elements are what? Made up of what? Small indivisible particles called what? Atoms. So let's look at the modification of this theory. This theory was actually, this first one was proven wrong by what? By the works of what? Lord Rutherford. By the work of who? Lord Rutherford. Actually, his full name is Ernest. Okay, no, just write Lord Rutherford. Lord Rutherford. That is from his work, from the work of Lord Rutherford. This one was proven what? Wrong. So it was discovered that atom is made up of what? Three main types of subparticles. We call what? Atomic what? Particles. Are we together? Yes. Number one. What we are doing since? No, I said that we are talking about the modifications. The first atomic theory, the first one was modified. Because the first one tells us that the atom is indivisible. That means there are nothing else you can divide. There are nothing else you can find inside what? Atom. That is smallest. You cannot divide it into anything. But according to the world, I remember the background of where I came from. That this other scientists continued doing work on this same atom. Then Lord Rutherford is one of them. In fact, Lord Rutherford had a lot of scientists under him. They have at least some good scientists that actually came up with some discoveries. Now work with him in his laboratory anyway. Most of the work, let me not go deep, just understand it that Lord Rutherford work was able to prove this first theory wrong, because the work discovered, through the work, it was discovered that the atom has what? Subatomic particles. The one that is inside the world, particles inside the world, atom. And the structure of the atom is made of these particles. The three main examples of them are what? Protons, what? Proton, neutron, and what? Electron. Proton, as I said before now, is positively what? Charged. Electron is negatively what? Charged. While neutron is what? No charge. It's neutral. Altogether, no charge. It doesn't have charge. Proton and neutron. It was actually discovered that from Lord Rutherford's work. This is the structure of the atom. The structure of the atom looks like this. The center, the nucleus, and what? Electron shells. This is how atoms look like from Lord Rutherford work. In fact, before he get to this Lord Rutherford work, J.J. Thomson did his own. I will say, we will still discuss it. And this is not how atom, according to J.J. Thomson, this is not how atom look like. But from Lord Rutherford work, we came to the that this is how atom actually what look like. We'll see discuss that. Now, from this Lord Rutherford work, the atom, the center here, the nucleus, we have protons and neutrons are in the what? Nucleus. While electron is on the what? Shell. Are we together? That's what Lord Rutherford discovered. So work of Lord Rutherford, his work proved this one wrong. That actually atom is not the smallest. The smallest. It's not the smallest. That's where the target is. That is not the what? Smallest. Because we have subatomic what? Particles. Is it clear? That's how the first rule was what? Disproved. Now let's go to the second one. So he said that the atom is made up of three main types of subparticles: the proton, electron, and the what? Neutron. and it is not an indivisible solid. Peace is not indivisible. It is divisible. By the time we go down, you see also that it's what? Divisible. Let's go to the second one, the second theory. John Dalton's the second part of the theory says that atoms can neither be created nor destroyed. Atom can neither be what? Created nor destroyed. This second part has two parts. There's two things I want to explain on this second theory. If you are talking about ordinary, sit up. That's a wrong, bad class posture. If you're talking about, if you're tired, you can stand up and walk around. Okay? That one is allowed. So far you can listen to what I'm saying, but don't sit like that. You will start thinking about another thing. You won't even know. You think you're saying class. Now, if you are thinking about, if you are talking about ordinary chemical reaction, if you're talking about ordinary chemical reaction, yes, the second theory still holds for ordinary what? Chemical reaction. Because in ordinary chemical reaction, you don't destroy what? Atom. Did you destroy the atom? You don't. And you don't create any atom in ordinary what? Chemical what? Reaction. Are we together? You don't do that. If it is oxygen will remain oxygen even in chemical reaction. Oh yeah, stand up. Can you belly? Oh? You can be writing while doing that. Just in ordinary chemical reaction, like now water, hydrogen and oxygen react to form hydrogen and oxygen reacting to form what? Water, right? This is 2 here. This is what? 2 here. Good. Hydrogen and oxygen reacting to form water. In this is ordinary chemical reaction. In this reaction now, inside this water, oxygen is still there intact, it's not destroyed, and no new atom is created. It's only new molecule, true of us, which is water. Inside this water contains the two atoms the way they are, hydrogen and what? Oxygen. But the only difference is that the ratio they appear here now is different, true of us, but they are not destroyed. And no new atom is what? Created. That's why I said that the second theory still holds for ordinary what? Chemical reaction. But it does not hold in radioactivity. So this second one doesn't hold when it comes to what? Radioactivity. Remember in radioactivity we have nuclear. Have you heard of nuclear fission? Have you heard of it before? No. Nuclear fission and fusion. In nuclear fission, from the word nuclear, it means the nucleus is splitted. Nuclear, the nucleus, right? Fission means divided into two of us or pieces, right? In nuclear fission, an atom is divided into two. From the nucleus, the atom is destroyed in radioactivity. In nuclear fission, atoms are what? Destroyed. If nuclear fission give room to smaller what? Atoms. Where fusion means combine join of the two atoms together, right? Two nucleus together. That means in nuclear fusion, you can get smaller nucleus. They come together and form a different what? Atom. That one takes place in what? Radioactivity. Nuclear fission and nuclear fusion. So there is destruction of what? Atom. Because once If this is the atom, once the atom is divided into two, it has been destroyed, right? True or false? And it will form different what? Atoms. So atoms are what? Destroyed and created in reactivity or nuclear reaction. You can say nuclear reaction, not ordinary reaction. In nuclear reaction, atoms are destroyed and atoms are what? Created. So this second part of John Dalton's theory does not hold for nuclear what? Reaction. But it holds for what? For what? Ordinary what? Chemical what? Reaction. Is it clear? Is it clear? So that is the fault in this second theory. Now, let's go to the third theory. So that's why by the time we go into radioactivity, you understand these nuclear reactions very well, okay? You know, you see how much a lot of energy that is released in this radioactive reaction, nuclear reaction. Let us not go there. That is a foundation for what? Bomb. Atomic what? Bomb. You're hearing about it, right? Right? Let us not go there. We'll still go into it when we treat radioactivity. Now, so this is the issue with the second one theory. Now, let's go to the third one. The third one says that atoms of the same element are alike. Atoms of the same element are alike in every aspect and differ from atoms of all other what? Elements. The fault this third one has is that when isotopy was discovered, you know what is isotopy, right? You know what is isotopy? A phenomenon whereby an atom exists in what? Molecules. What is isotopy?
Isotopy is atoms with different
That is not, you are defining isotopes. No, it's the same idea. I'm just correcting. You continue.
isotopes are atoms.
Don't want to continue. Just say it after I'll correct you. Continue.
With different atomic number at the same time.
With different what?
Atomic number.
And the same mass number.
With different mass number at the same atomic number.
The same atomic number. That is not isotopy. Isotopes are atoms. Different atom we are with what? Atom with the same what? Atomic number but different what? Mass number. They're actually atoms of the same elements, but they have the same atomic number because they have the same atomic number, but they have different mass number. But isotopy is a phenomenon whereby, are we together? Isotopy is that phenomenon whereby atoms exist with different what? The same what? Atomic number but different what? Mass number. That is isotope. But isotopes are the atoms themselves. Okay? Please note the differences. A lot of people make this mistake. Now, when isotopes were discovered, existence of isotopes were discovered, this third part of John Dalton had issues. When isotopes were discovered, this third rule became faulty. Do you know why? Look at it now. It's saying that atoms of the same elements are alike in every aspect. But it's not true. Isotopes are atoms of the same element. That's why you can see chlorine. Chlorine has an atomic number of what? 17. We have chlorine 35. and chlorine what? 37. Look at it. Chlorine. We have chlorine 35 and chlorine what? 37. Look at it. They are the same thing. Chlorine. They have the same atomic number, 70, but their mass number is not the same thing. So why would John Dalton tell us that two of them, that atoms, these are atoms of the same element. The element is chlorine. These are the atoms. How can you say that the two of them are alike in every aspect? Are they alike in every aspect? These two things, are they alike in every aspect? So where do they differ? Mass number. I mean, I see why the third theory has fault. Because he said that atoms of the same element are alike in every aspect. It's not true. Because existence of isotopes shows that atoms of the same element must not be alike in every one. They can't be alike in every one aspect. Because isotopes are not alike in every aspect. When we enter into isotopy, we know the differences between isotopy in their physical properties. You know the differences in their physical properties. They may have the same chemical property, but their physical properties always have issues. I don't want to go deep into that, but just realize that existence of hypothesis proves this third rule or third theory was wrong. So I use chlorine now as an example. Now chlorine has two different atoms or isotopes which differ in their. And let me ask a question. What do you think? Let me know those that can answer. Just a side. We have not treated this in class, but I just want to know, just to ignite our mind. Look at these two. Yes, we know that these two isotopes, these are chlorine 35 and chlorine 37 are isotopes of what? Chlorine. Good. Now, what is the main cause of this difference between the two of them? What is the main cause of the difference between the two of them? Difference in what? It's mass number. But what is different? What is mass number? Mass number is what? Number of what and what? Mass number of an atom is the sum, the sum of proton and what? The neutrons the atom contains. Are we together? Are we together? That's the what? That's the what? That's the what? The mass number of that atom. Now look at this. Look at this. I remember that I have already told you here that atoms, in an atom which is neutral, atom is neutral. Number of electron and number of proton are what? The same thing. Do you agree with me? Do you agree with me? In an atom which is neutral, we know that atom is neutral. Number of proton and number of electron is what? The same thing. That means if this contains chlorine that has 17 atomic, and you also know that atomic number is the number of proton. Hope you know. You can call it atomic number. You can also call it what? Proton number. Are you aware? Are you aware that atomic number is equal to the number of proton, right? Now, if this is atomic number is 17, that means the number of proton in chlorine is what? 17. And because chlorine here is an atom, not an ion now. Therefore, the number of electron is also what? 17. True of us? Then if number of electron is also 17, then what is number of neutron in chlorine 35? This is mass number, right? And what is mass number? Sum of proton and neutron. And this chlorine has 17 proton. True of us? So what is the number of neutron in this chlorine? 18. So in chlorine 35 we have what? 18 what? Neutron. Then in chlorine 37, how many neutron are there in chlorine 37? 20. 20. So they have, in chlorine 37 we have 20 neutrons. In chlorine 35 we have 18 neutrons. So actually, what caused the difference in the isotope is what? Number of what? Neutron. Number of what? Neutron. What is there? I don't understand. What is mass number? So chlorine has how many? What number of proton in chlorine? So what number of neutron in chlorine 35? You have already told me here now that mass number is number of proton and neutron. You said it now. And I ask you again, what is number of proton in chlorine? You see, you say 17. And I'm not asking you now, what is number of neutron in chlorine? I think you should be able to answer that. Okay, let me start again. What is mass number? So what is mass number of chlorine 35? Then what is number of proton in chlorine 35? Then what is number of neutron in chlorine 35 now? Is what? 35 minus 17 is what? Is what? Tell us now. 18. Have you seen where 18 came from? So do the same thing here. You get what here? 20. We are trying to say, I'm trying to let you know that actually what caused the difference between these isotopes is actually the difference in their number of what? Neutron. Their neutron content. That's the what differ, the main difference between the two isotopes. Am I communicating? Good. So this is side talk, but it's good to use it to prepare our mind, solidify on what you have already learned in your school. At least I believe there's nobody here that have never heard anything about chemistry at all, or even basic science. But I'm just using this to prepare our mind, make you understand what you knew before. Maybe you didn't know it this way. That's why I'm doing this. Okay, is it clear now? So let's continue. Now, so actually is the neutron content of this isotope that caused the what? The difference. Okay, chlorine 35 has 20 neutrons. Why chlorine 37 has 20 neutrons? Why chlorine 35 has what? 18 what? Neutron. Are we together? Are we together? Good. So because they have the same atomic number, they have the same chemical what? Chemical what? Properties. But their physical property is not what? The same thing. Chlorine 20. Which of them did you think should be heavier? Chlorine 37, right? It will be heavier than chlorine what? And because of that, it also affects their density. Hope you know. It also affects their what? Density. True of us. Because density is mass over what? Volume. The same, if they may have the same volume, but one will be more dense than the other one. Which will have more density? 37 will have more density. True of us. If they have this, if you get the same volume of the same volume, if you present the same volume of chlorine, if you present the same volume of chlorine 20 and the same volume of chlorine what? Let's say you get 50 cm cube of chlorine 37 and 50 cm cube of chlorine 35. 50 cm cube of chlorine 37 will be heavier than that of chlorine what? 35. So their physical property will do what? differ. But because they have the same number of proton, which is sent with the same number of what? Electron, their chemical reactivity will be what? Similar. Are we together? So atoms of the same elements are not alike in all aspects. That's what we are saying here. So that's a fault on the third what? Part of John Dalton's atomic what? Theory. Does it make sense? Does it make sense? Good. Now let's continue. Let's go to the fourth one. Let's look at the fourth one. The fourth one says that when atoms combine, with other atoms, they do so in simple what? Ratio. When atoms combine with what? Other atoms, they do so in what? Simple what? Ratio. Good. This one also has area where it's correct, and it's where it still holds, and it has area where it doesn't hold. Now let me give you an instance. In inorganic reaction, chemical reactions, yes, it holds. As you can see here, these things are inorganic. Hope you know. Hydrogen, oxygen, water, sodium and chlorine. Sodium, right? We have maybe sodium. Let's say sodium hydroxide and what? And hydrochloric acid. Simple whole number ratio. We form sodium chloride, and sodium and chlorine in sodium chloride are in ratio of what? 1:1. 1. Three of us. You are looking lost. This fourth part said that atoms combine with atoms of what? With other atoms in simple what? Whole number what? Ratios. Is that not what we discuss in compound formation? Is that not? Yeah, that's what we say, that a compound like water contains hydrogen and oxygen in ratio of what? 2:1. They are simple whole numbers, is not? Now when sodium chloride, when sodium hydroxide reacts with hydrochloric acid, okay, those ones are not atoms, they are compound. Let me use atoms so I can describe this better. Let me use atom. Let me not use compounds. I've mentioned what? Hydrogen and what? Oxygen to form what? Water. This is what? 2. This is what? 2. There are 4 hydrogen here. 1, 2. 2 times 2, 4. 4 is here. 2 is here. Oxygen 2. If you watch the ratio of the combination, here is 2:1. Hope you know. Even though here hydrogen is what? 4. Oxygen is what here? Oxygen is what here? 2. Basically is what? This 2 divide itself 1. 2 divide 4 is what? 2. So it's ratio of 2:1. In the compound here, which is water, they appear in ratio of what? As atom, 2:1. It's still 2:1. Hope you know. Because this is 2 times 2, which is 4. This is 2. This 2. This oxygen gets share of this 2 in front of it. Hope you know. So making it what? 4:2, which is written as what? 2:1. So they combine in simple whole number what? Ratio. If you say hydrogen and the nitrogen now to form an ammonia process, in ammonia, you have something like this. In ammonia, okay, let's balance this. This is 2. This is what? 3. This is 2. It's balanced now. Okay? It's balanced. Hydrogen is 6. 2 times 3 is 6. Nitrogen is 2 here. 2 here. So it's balanced. Now, they combine. This is 6. This is 2. This is also what? Hydrogen is 6 here. And 2. If you break it down, if you take it to the simplest, this thing, we have 3:what? 1. So hydrogen and the nitrogen combine in ratio of 3:1 to form ammonia, which is also a ratio of what? 3:1. So they combine a simple what? Whole number what? Ratio. In inorganic reaction. But when it comes to organic, they don't. It's not a simple whole number ratio. That's why you start seeing carbon combining. We call it catenation. Have you heard of catenation before? Combining in what? Chains, carbon chains, right? And apart from that, even sugar, even sucrose. Remember what did we say? Give us the formula of sucrose. I gave in this class. Fast. Formula for sucrose. C what? C12. H what? 20 and what?
11.
Look at this thing. Is this a simple whole number ratio? This is an organic compound. Sucrose C12, H22, O11. This is even the smallest of organic compound. You see the one that has more than this. This is not a simple whole number ratio. It's not simple. This is large. It's not simple. Even though when you are treating organic compound, this one is really small. When you are treating what? Organic compound. So the fourth part of the Dalton's atomic theory is only holds for what? Inorganic what? Compound. Not for organic what? Compound. Is it clear? Is it clear? Good. That's how they modify this what? Fourth part. He said that the statement is generally true only for inorganic what? Compound. Carbon form a very large organic what? Molecules. So I just mentioned sucrose. Protein. Have you seen protein? Have you seen protein chain? Okay. DNA. Do you know how DNA look like? Do you know how many atoms? Do you know how many atoms combine to form the DNA chain, the DNA structure? Do you know how many of them? So those ones are not simple a simple whole number ratio. These ones are thousands. They are very large, hundreds. They are very large. So carbon form very large organic molecules such as protein, fat. Who has seen structure of fat? Even starch. Oh, polysaccharide. Polysaccharide is chains, right? Chains of what? Polysaccharide. So it's not just a simple whole number what? Ratio. Are we together? Are we together? There are even some inorganic compounds that even have chains, but not to compare with organic anyway. There are some inorganic that are not even in this what? Simple whole number ratio. Something like some complex formed by silicon. They have large number of atoms. So that's why how they disprove this what? Fourth what? Part of the Dalton's atomic what? Theory. Are we together? Are we together? So only the last one maintains, it still maintains to today. That say that all chemical changes result from combination or separation of atoms. It's true. You can't talk of chemical reaction without combining atoms. True of us. Is when atoms are combined that they form what? Compound. It's not true. Whether in organic, whether it is in inorganic, it's still the same process. Chemical compounds are formed, whether simple or complex compounds, are formed by what? Addition, combination, and what? Separation of what? That's why we have a topic we call bonding. Chemical what? Bonding. Before a chemical reaction will take place, there must be bonding. Either it is ionic or equivalent, or it is covalent, be it ordinary covalent, be it dative, or what? Coordinate covalent. Anyone, there must be what? One or two form of bonding. If it is inorganic compounds are mainly ionic, covalent, dative is there, but most of the organic are mainly what? Covalent. True of us. So that is what the summary and the modifications of what? Dalton's what? Atomic theory. So if you are asked now to stand up and discuss Dalton's atomic theory, I believe we can discuss it with confidence, either as spoken words or written. I believe we can do that. Who cannot do it here? You cannot do it here. Sorry. At this junction, I don't know what else to do to you. You need to help yourself. One, you came late. He came late, right? So how do we expect to go back? Maybe after you listen to our lectures. Okay? Go to YouTube and listen to it. It's self-explanatory. I can't be going back and coming forward all the time. That's why I record the lectures, so that you can listen to it and have a better understanding, or even make notes from it if you're not able to make notes here. But I don't know how many of you that listen to these lectures. Who listen to the lectures? Let me see your hands up. Who? Nobody. If you miss it, okay. All right. So that is all about that thing that atomic theory. What's time? We spent 2 hours on this class. Okay. Are you tired?
Yes.
Are you tired? Okay, if you're not tired, let me see your hands up. If you're not tired, let me see your hands up. If you're tired, let me see your hands up. No, you must belong to one. If you're tired, raise your hand. If you're tired, raise your hand. I want to count now. Those that are tired and more will rest. If those that are not tired are more, those that are tired will be here with us. They'll stand up and be going around and regain their strength. So let me count now. If you are tired, let me see your hands up. Do it well. If you know what you are doing, do it well like this. I will only count those. I will count only the one. Now I will not count this one. I count this one. Where do you belong? This boy. Raise your hand properly. Let me be serious about this now. Let me know what I'm doing. 4 are tired. If you're not tired, let me see your hands up. Izu Amunachi, where do you belong to? You don't know if you're tired or you don't know if you're not tired. Anyway, we are 6 here. Maybe we are 6 human beings here. No, I think maybe it's only human beings that know what I want is happening to them, right? So, Okay, I think I don't even believe in giving more than 2 hours lecture at a stretch. It's not a good thing. So I think we'll stop here. Let's rest for a while, then we'll continue. If we come back, we'll continue with physics. We'll switch into another subject. No, mathematics, sorry. We'll switch into another subject so that, if you talk about one subject for a long time, you get bored. You go into another subject. So if you come back, we'll go into mathematics and see what we can make out of maths today. All right. Okay, when do you want to come back? You're not serious. We are very unserious. I won't take that one. Tell us, just how many minutes do you want to stay? Let me hear you.
1 hour.
Someone say 1 hour.
1 hour is
1 hour is 12:30.
No, just 12.
Okay, I'm hearing. Okay, I have two. This thing. You must belong to one here now. I won't take anybody that does not belong to one. You must belong to one. So someone said 30 minutes, and one said 1 hour. If you have for 30 minutes, let me see your hands up. If you have for 30 minutes, let me see your hands up. If you have 1 hour, let me see your hands up. No, I know. I won't accept this vote. You must belong to one. I won't take this one. I won't take it. I won't take this one. If you have 30 minutes, let me see your hands up. Nobody go for 30 minutes. If you have 1 hour, let me see your hands up. Okay, we'll convert by 12:30. All right.